Static buildup occurs when electrical charges accumulate on an object due to imbalances between positive and negative charges. In the vicinity of power lines, the presence of strong electric fields can induce static buildup on nearby structures, including highway signs. The electric field generated by power lines can polarize materials, separating positive and negative charges. This polarization can create a static charge on exposed surfaces. When the static charge becomes significant, it can discharge as an electrostatic discharge event, resulting in the sudden release of energy. If a person touches the charged structure, they may receive an electric shock. There are several personal protective equipment and dissipation methods. Firstly, insulated gloves and tools. These can protect against electrostatic discharge by preventing direct contact with charged surfaces. Secondly, non-conductive clothing. This helps minimize the risk of electrical shocks by reducing the body's ability to conduct electricity. Thirdly, electrostatic discharge shoes. These shoes can dissipate static charges by grounding the wearer. Dissipation methods are also crucial. Firstly, grounding. Connecting the structure to the ground using a conductive material can provide a path for static charges to dissipate. Secondly, anti-static coatings. Applying anti-static coatings to the structure's surface can help prevent charge buildup. Thirdly, static dissipative mats or flooring. Placing these materials near the structure can provide a path for static charges to ground. Other considerations are also essential. The closer a structure is to a power line, the higher the risk of static buildup. Dry and windy conditions can increase static buildup. Regular inspection and maintenance of the structure can help identify and address potential sources of static buildup. When communicating with the power company, document the issue. Keep detailed records of the shocks experienced, including the dates, times, and locations. Provide evidence. Submit photos or videos that demonstrate the static buildup to the power company. Request mitigation. Politely request the power company to investigate the issue and implement appropriate mitigation measures. If the power company is unresponsive or unwilling to address the issue, consider consulting with a legal professional to explore your options. Understanding electric field induction. The electric field generated by power lines can polarize materials, separating positive and negative charges and creating a static charge. Electrostatic discharge, or ESD, happens when the static charge becomes significant, discharging as a sudden release of energy, potentially shocking someone who touches the structure. For personal protective equipment, firstly, think insulated gloves and tools to prevent direct contact with charged surfaces. Secondly, wear non-conductive clothing to minimize electrical conductivity through the body. Thirdly, use electrostatic discharge shoes to ground and dissipate static charges. As for dissipation methods, firstly, grounding the structure with conductive materials provides a path for static charge dissipation. Secondly, anti-static coatings on surfaces prevent charge buildup. Thirdly, static dissipative mats or flooring near the structure offer a grounding path. Consider how the proximity of the structure to power lines increases the risk of static buildup. Also, recognize that dry and windy weather worsens static. Regular inspection and maintenance are key to spotting and addressing static sources. When reporting issues to the power company, keep a detailed record of shocks, including times and locations. Supplement your report with photos or videos as evidence of the static buildup. Politely request the power company to look into the problem and put mitigation measures in place. If the power company is unresponsive, seeking legal advice may be a next step. Structures near power lines experience static buildup due to electric field induction, where the power line's electric field polarizes materials and creates charges. When these charges build up enough, they discharge as electrostatic discharge, which can shock individuals. Mitigating these shocks involves personal protective equipment like insulated gloves, non-conductive clothing, and electrostatic discharge shoes. Dissipation methods include grounding structures, applying anti-static coatings, and using static dissipative mats. Factors like power line proximity, weather, and maintenance practices also affect static buildup. Effective communication with the power company, including detailed documentation and requests for mitigation, is crucial for resolving the issue. If the power company fails to act, legal options should be considered. Structures located near power lines are prone to static buildup due to a phenomenon called electric field induction. The electric field emanating from the power lines can cause a separation of charges within the materials of the structure, leading to a positive or negative charge accumulation. When this static charge becomes sufficiently high, it can discharge in the form of electrostatic discharge, resulting in a noticeable shock upon contact. Addressing this issue requires a multifaceted approach involving personal protective equipment, dissipation methods, and proactive communication with the power company. Regarding personal protective equipment, several options can minimize the risk of electric shock. Insulated gloves and tools prevent direct contact with charged surfaces, acting as a barrier against the flow of electricity. Non-conductive clothing made from materials that do not readily conduct electricity reduces the body's ability to become a pathway for electrical discharge. Electrostatic discharge shoes, designed with conductive soles, provide a path for static charges to dissipate harmlessly to the ground. In addition to personal protective equipment, implementing effective dissipation methods can reduce static buildup on the structure itself. Grounding involves connecting the structure to the earth using a conductive material, providing a low-resistance path for static charges to flow to the ground. Anti-static coatings applied to the surface of the structure help prevent the accumulation of static charges by promoting charge dissipation. Static dissipative mats or flooring placed near the structure provide a conductive surface that facilitates the grounding of static charges. Several other factors influence the risk and severity of static buildup. The closer a structure is to a power line, the stronger the electric field and the greater the potential for static buildup. Weather conditions, particularly dry and windy environments, can exacerbate static buildup by reducing humidity and increasing charge separation. Regular inspection and maintenance of the structure can help identify and address potential sources of static buildup, such as loose connections or damaged insulation. Effective communication with the power company is crucial for resolving static buildup issues. Document any incidents of electric shock, including the date, time, and location. Provide the power company with evidence of the static buildup, such as photos or videos. Request the power company to investigate the issue and implement appropriate mitigation measures. If the power company is unresponsive or unwilling to address the issue, consider consulting with a legal professional to explore your options. Static electricity buildup on structures near power lines arises from the strong electric fields causing charge separation within the structure's materials. When these charges accumulate sufficiently, touching the structure can result in an electrostatic discharge or a shock. To mitigate this risk, personal protective equipment plays a vital role. Insulated gloves and tools prevent direct contact with charged surfaces. Non-conductive clothing minimizes the body's ability to conduct electricity, and electrostatic discharge shoes help dissipate static charges to the ground. Implementing effective dissipation methods is also crucial. Grounding the structure provides a path for static charges to safely discharge. Applying anti-static coatings to surfaces can prevent charge accumulation, and static dissipative mats or flooring offer a grounding path for charges. Other factors to consider include the proximity of the structure to the power lines, as closer proximity increases static buildup. Dry, windy weather can also exacerbate the problem. Regular inspection and maintenance can help identify and address potential sources of static. When communicating with the power company, maintaining detailed records of shocks, including dates, times, and locations, is essential. Providing evidence, such as photos or videos of the static buildup, can strengthen your case. Request the power company to investigate and implement mitigation measures, and if they are unresponsive, consulting with a legal professional may be necessary. Static buildup on structures close to power lines happens because the strong electric fields polarize the material, separating positive and negative charges. When enough charge builds up, it discharges as an electrostatic shock. To prevent shocks, use personal protective equipment. Insulated gloves and tools stop direct contact. Non-conductive clothes reduce electrical flow through the body. Electrostatic discharge shoes ground the charge. Also, ground the structure to dissipate static. Use anti-static coatings to prevent charge accumulation. Static dissipative mats help ground charges as well. Consider that closer structures to power lines will build up more static. Dry, windy weather increases static too. Regularly inspect and maintain structures. Document shocks with dates, times, and locations. Provide photos or videos as evidence to the power company. Request an investigation and solutions from the power company. If they don't respond, consider legal action. Electrical charges can accumulate on structures near power lines, leading to static buildup due to the strong electric fields. This occurs because the power line's electric field can polarize the materials, creating imbalances between positive and negative charges on the surface. When the static charge becomes significant, touching the structure may result in an electrostatic discharge or a sudden shock. Several measures can be taken to mitigate this risk. As a starting point, the use of personal protective equipment is essential for personnel working in proximity to the affected structures. Insulated gloves and tools can prevent direct contact with charged surfaces, shielding workers from potential shocks. Non-conductive clothing minimizes the risk of electrical shocks by reducing the body's capacity to conduct electricity. Electrostatic discharge shoes can also be employed to dissipate static charges by grounding the wearer. Beyond personal protection, various dissipation methods can be implemented to reduce static buildup on the structure itself. Grounding the structure through the use of conductive materials provides a pathway for static charges to dissipate safely into the ground. Anti-static coatings applied to the structure's surface can help prevent charge accumulation. The use of static dissipative mats or flooring near the structure can also provide a grounding path for static charges. Several other factors can influence the extent of static buildup. Proximity to the power lines directly impacts the risk, with closer structures experiencing higher levels of static. Weather conditions such as dry and windy environments can exacerbate static buildup. Regular inspection and maintenance of the structure can help identify and address any potential sources of static buildup. Finally, it is essential to maintain effective communication with the power company. Keeping detailed records of experienced shocks, including dates, times, and locations, is crucial. Providing photographic or video evidence can strengthen your case. Submit a request to the power company to investigate the issue and implement appropriate mitigation measures. Should the power company prove unresponsive or unwilling to address the problem, seeking legal counsel may be a necessary step. Near power lines, structures can accumulate static due to electric fields causing charge separation. This leads to electrostatic discharge and shocks. Firstly, wear insulated gloves and use insulated tools to prevent direct contact. Secondly, wear non-conductive clothing to minimize electrical conductivity through the body. Thirdly, use electrostatic discharge shoes to ground static. Connect the structure to ground for safe charge dissipation. Apply anti-static coatings to prevent charge accumulation. Use static dissipative mats for grounding. Proximity to power lines increases static. Dry, windy weather increases static. Inspect and maintain structures regularly. Keep records of shocks with times and locations. Provide photos and videos to the power company. Request investigation and mitigation. Consider legal action if the power company doesn't respond. Static electricity on structures near power lines is due to electrical charges accumulating because of imbalances between positive and negative charges. The electric field from the power lines can induce this static buildup on nearby structures, including highway signs. This occurs due to electric field induction. The electric field generated by the power lines can polarize materials, separating positive and negative charges. This can create a static charge on exposed surfaces. Electrostatic discharge occurs when the static charge becomes significant. It can discharge as a sudden release of energy. If someone touches the charged structure, they may receive an electric shock. Personal protective equipment can help. Insulated gloves and tools can protect against electrostatic discharge by preventing direct contact with charged surfaces. Non-conductive clothing helps minimize the risk of electrical shocks by reducing the body's ability to conduct electricity. Electrostatic discharge shoes can dissipate static charges by grounding the wearer. Dissipation methods are also helpful. Grounding connects the structure to the ground using a conductive material, providing a path for static charges to dissipate. Anti-static coatings applied to the structure's surface can help prevent charge buildup. Static dissipative mats or flooring placed near the structure can provide a path for static charges to ground. Other considerations are relevant. The closer a structure is to a power line, the higher the risk of static buildup. Dry and windy conditions can increase static buildup. Regular inspection and maintenance of the structure can help identify and address potential sources of static buildup. Communication with the power company is important. Document the issue by keeping detailed records of the shocks experienced, including the dates, times, and locations. Provide evidence by submitting photos or videos that demonstrate the static buildup to the power company. Request mitigation by politely requesting the power company to investigate the issue and implement appropriate mitigation measures. If the power company is unresponsive or unwilling to address the issue, consider consulting with a legal professional to explore your options.